Welcome to installment number 6 of the functions and relations revision. For this question, if g of x is equal to negative 4x squared, sketch the graph and state the range for. Firstly, if we have no restriction in the domain, what's it going to look like? So if we're going to sketch the graph, it is a negative quadratic. So in this case, it's going to be all underneath the x-axis for y and for x, and the graph will look something a bit like that, and the range is going to be everything below the x-axis and including the x-axis, so the range will be equal to negative infinity through to 0. Now, for the second part of this, it is the same function, but we have a restriction on the domain. So what would be a good idea is if we work out what the corresponding y values are. So when x is equal to negative 2, then y will be equal to negative 4 by negative 2 squared, which will equal negative 2 squared is 4, negative 4 by 4 is negative 16. And similarly, when x is equal to 3, y will be equal to negative 4 by 3 squared. 3 squared is 9. 9 times negative 4 is negative 36. So in this case, the graph is going to be the same shape as the first one. Almost, well, same shape, but we're going to apply the restriction in the domain to it. So y there. So we have our graph, and it will go a little bit deeper in the positive end of x than it will in the negative. Something like that, where this point here is negative 2 and negative 16, and this point here is 3 and negative 36. So now to state the range, we do actually now have a restriction there because it goes from negative 36 up to 0. So that tells us that our range will be negative 36 to 0. For the next part, what we're doing is just slightly changing the domain. So in the first instance, we have a square bracket which is going with the negative 2, round bracket going with the 3. Now, if we look at the range for the previous one, and we look at the negative 2x value, so the coordinates that we had here, they weren't going to have any impact on the range. It's the ones on the other side there, so we need to consider square brackets or round brackets with that. So for this one here, the 3 has a round bracket next to it, so that tells us that our range for this one would be round bracket, negative 36 and 0. It is still going all the way up to 0, so it equals that. For the last one, again for the same reason, because the x value of negative 2 in this particular restriction of the domain doesn't have an impact on the range for it, we can basically going to have the same again. There's the dog barking at something outside. Should I go and investigate? Maybe I should. Let's flick to the next page anyway. So I wander outside to investigate the dog, and the dog runs away with tail between its legs, which is a sign of guilt on behalf of the dog, I do believe. And nothing else was there. So let's have a look at this next question. State the range for the function y is equal to 1 over x plus 3 with a domain of 0.5 through to 2. So what this graph is going to look like x and y is, it's been shifted up by 3, so we will have an asymptote going through there at y equal to 3, and the graph will have a shape as it comes down. Draw that bit again. Going something like that. Now, we're told that our domain has a restriction, 0.5 through to 2. So what we need to do is to find the corresponding y values in order to work out the range. So if we have x equal to 0.5, then y is equal to 1 over 0.5 plus 3. 1 over 0.5, how many halves are there in 1 is 2. So 2 plus 3 is equal to 5. And then, when x is equal to 2, y will be equal to 1 over 2 plus 3, which equals 3.5. Or if you prefer it as an improper fraction, 7 over 2. So that tells us that the range for this particular function will be, we're going from 7 over 2 all the way up to 5. If we look at the question, we have the equals component for both of those, so we're going to use some square brackets here. And that's the answer to that question. Let's move on to the next question. Sketch the graph and state the range here. We're going to go like so for x and for y. Now we have a couple of key points here to look at. X is 0, and we'll call that one there 3. Okay, and on the y-axis we need to go up a little bit higher than 6, so I'll go 2, 4, 6, like so. We'll just get a bit more of a scale onto there. And to sketch the graph, so for the first part of this, we have x less than or equal to 0, negative x plus 6. So when we get to 0, nice little filled in circle there, it has a gradient of -1, so it goes down 1 for every one that it goes across, but we need to go in the negative direction, so we're going to go up 1 and across 1 in the negative direction, roughly, and extend it through like so. So that graph will look something like that. Then for the second part of it, between 0 and 3, we have x plus 2. So when x is equal to 0, y is equal to 2. It doesn't, in this case here, it doesn't actually touch 2. It starts at 2. That's our limit. The other end of it, when we go to x equals 3, then y will equal 3 plus 2 from the equation, which equals 5. So at x equals 3, y will equal 5. It's the other end of it, so we'll just join that up with a straight line. And for the third part of this, we're going x greater than equal to 3. So for this one here, we'll do the same sort of thing. When x is equal to 3, then y will equal 2 by 3 plus 1. 2 3s are 6 plus 1, so that's equal to 7. So that tells us we go up to 7 here, about there. We'll have a nice little circle there. And the gradient we have is 2, so it goes up 2 for every one that it goes across, so it's going to be a fairly steep graph. The graph will go up like that. Okay. Let's move on. Oh, we have to state the range of this one, don't we? So the range will be, just had a bit of a cough then. The range is going to be signified by, firstly, this bit here. It doesn't touch either end of that. So that's going to be 2 to 5. And we also have the next part is from 6 upwards. So that's going to be 6 and infinity. Round bracket for infinity. Does it equal 6? Yes, it does. Square bracket there. So that's what our range is equal to. Okay, so that's that question. Let's move on to the next one. Sketch the graph of y equals x squared plus 2x plus 6 and state its range. Now I'm going to turn this into turning point form. Y equals x squared plus 2x. Get the 2 and divide it by 2, which is 1. So I go plus 1 squared minus 1 squared plus 6, which equals x plus 1 squared minus 1 plus 6 is plus 5. So that tells us that we're going to have a turning point at -1 and 5. And it is a positive x squared graph because of that there. So it's going to be a cup-shaped graph. So if we're going to sketch the graph, there's going to be no x-intercepts whatsoever. And from the original part of the equation up here, when x is equal to 0, the rest of it's crossed out. So it tells us that our y-intercept is going to be plus 6. So the graph is going to look like something like that, where we have a turning point at -1 and 5, and we have an a y-intercept of 6. Okay, and the range for this one, the lowest point that we have is 5, and it just goes upwards. So our range is going to be 5 to infinity. Round bracket for infinity. Does it touch 5 in the y? Yes, it does. So That's what our range is going to be for this particular question. Let's move on to the next question. Sketch the graph of x minus 7 squared plus y minus 7 squared equals 4 and state the range. So this is going to be a circle graph with the centre at 7 and 7, and the radius is the square root of 4, which is equal to 2. So the graph of this one that's the centre of our circle, and it has a radius of 2, so it's just going to be a little circle like so, which will go as high as 9 in x and as low as 5 in the x, and similarly it'll go as low as 5 in the y and as high as 9 in the y. So the range that we'll have for this question here is it goes from 5 up to 9, touches both of them. So our range, which is that bit there, will be 5 to 9. And that's that question there. So thanks for watching.